Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to Dr. Said and Mr. Farid. So today I will present my bachelor degree project with entitled of Development of an Automated Computer Numerical Control (CNC) Engraving Router System. So my name is Mohammad Nor johari, and I am from BEEA 1/2. Okay, this is the content that I will present to you. Have about 7 topics. The first topic is introduction. The second is problem statement. Third, objective and scope, methodology, initial result, conclusion, project planning. So for the first topic, introduction, what to know about CNC. CNC is stand for numerical control, computer numerical control. Before CNC is found, the machine is controlled by NC, which is NC is a G code that will be key in manually. So with the technologies nowadays, the NC can be key in by the computer. So computer program the G code and arrange the G code, so CNC is created. CNC stand for Computer Numerical Control. A CNC machine is a programmable machine able to conduct CNC machining operation on its own. This is automation. It is automatic from the first step until the product is good, until the product is finished. Okay. CNC machine produce high precision manufacturing products, drive by geometry, coordinate by geometry code, which is normally we call it G code, in variety of axis and feeder. What is the mean of axis and feeder? Axis in a machine, there is many type of machine in this world. So some machine have 2 axis, 3 axis, 4 axis, 5 axis, 6 axis, and maybe have more than 6. I'm not sure, but the main point is G code can control variety of axis and feeder. Feeder is what? Feeder is the process. So let's say for an example, milling. So with the milling process, it use spindle. Spindle is a feeder. So for laser cutting, the laser cut is the feeder. All right. I think this that is clear. Okay. So machining, CNC machining have 2 types. The first type is additive manufacturing. The second type is subtractive manufacturing. What is additive manufacturing? What is subtractive manufacturing? Additive manufacturing is adding, injecting, extruding a material, and additive process of combine layer of material rapidly. So the material is what is called inject out, they add by layer until get a product. It is different with subtractive manufacturing. Subtractive manufacturing is a process of engraving, cutting, turning a material and remove layer of material rapidly. So as an example, this is a block, wooden block or aluminum block. The process of subtractive manufacturing is it will cut the surface of block until we get a shape, desired shape. This is the example of a shape. A cup. This is the example. All right. So this is additive manufacturing example. As you can see, this is 3D printer. In additive manufacturing, this is called extruding process. There is a variety type of type in additive manufacturing, but I am showing to you what I show this in this slide is 3D printing. So subtractive manufacturing. This is the picture of subtractive manufacturing, which is it will cut the block until we get the shape that we want. Right? So this is milling, CNC milling process. All right. So basically, to operate a machine, to operate a CNC machine, we have 4 steps. The first step is design a CAD model, which is design a shape, any shape, with using a CAD. What is CAD? CAD is computer aided design, which is a software to make a design. All right. And then convert to CNC program. What is the meaning of CNC program? All right. From the design of CAD, we need to convert the design to a G code, which is the G code is the code or language that a machine can read, and it will move according to the G code programming. That's why we call CNC, not NC. CNC, computer will automatically convert it. We don't have to push it manually. G90, blah blah blah, G20, M300, and 500, and whatsoever. No need. So this is CNC process. From the CAD shape, convert it into a G code using any software that is suitable. Okay, that's the second step. The third step is after the G code is created, before we run a machine, we must prepare the machine first. This is the main or basic step of before we execute any operation, CNC machine or any machine in this world. It doesn't care CNC or whatever types of machine. So machine preparation is important for a safety precaution, for a machine to be prepared before it execute any process. Machine preparation is the most basic things that we need to know in a machining process. Okay, after the machine is prepared, the situation, the machine or the environment is secured, safe to run, so we execute the operation. Either the operator execute the operation or we on our own execute the operation, which is start the machine to make something miracle. All right. So next, type of CNC machine. Okay, in this presentation, I will present only 3 types of CNC machine. There is many types of CNC machine in this world, but I will explain or introduce just these 3 CNC machine, which is these 3 process or these 3 type of CNC machine is related with my project, my research. Okay, for the first machine is CNC router. Okay, CNC router performing engraving, cutting, drilling. So CNC router is in subtractive manufacturing. Okay, CNC laser. The second one is CNC laser. CNC laser is performing a cutting, engraving, burning. Okay, the CNC laser is also and subtractive manufacturing in category subtractive manufacturing. Okay, yeah, and the third machine is CNC plotter. CNC plotter perform cutting, drawing, and plotting, which is CNC plotter can be in 2 different world, which is can be subtractive, can be additive. Additive when the machine is programmed or set to draw or do anything that editing on the surface of the workpiece. and can be cutting. Why? Because sticker at the usually we make a sticker, we it's called order a sticker at the at a printing store. The sticker came to us with absolutely nice cutting. So CNC plotter is the machine that cut the sticker. All right. So we will go through one by one. Okay, CNC router is a machine that manually used by hand, manually used by the carpenter. Manually used by a carpenter. This is a router. As you can see, this is a router, and this is, yes, this is a router too, but in CNC, in a CNC machine. The process have been integrated manually to CNC router, which is machine control the movement, the shape, the whatsoever. The computer control the router. So at the past or before the CNC router is there, usually carpenter use manual router. Okay. CNC router to produce precise product of lighter material, which is wood, composite, plastic, acrylic, foam, and may work on soft metal like aluminum. This is the material that CNC router can cut or can engrave or drilling whatsoever process. Only this material can be done. For titanium and other hard component of metal, we cannot use CNC router. We need to use CNC milling. Okay, but CNC milling is not in this study. So we go to next machine. Okay, next machine is CNC laser. Okay, what is laser actually? Laser is light amplification by simulated emission of radiation. So this is, laser is stand for this term. Before this we know laser, but in the real, but it stand for this. It stands for light amplification by simulated emission of radiation. Okay. It perform cutting, engraving, burning, as you can see here in the figure side here. Okay. The material is targeted by a focused laser beam which melt, burn, vaporize, or it blown away by a jet of gas, leaving an edge with a high quality surface finish. Also, okay, as you can see from this picture, we can see there is no debris or any substance that is not which is what's called, we don't want. There is no burr or nothing. The surface is so clean. This is the specialty, the special of CNC laser. Okay. Right. So this is CNC plotter. Yeah. Okay. In this picture is a marker drawing CNC plotter, which is the plotter draw a picture on the paper. But this plotter, this CNC plotter is draw a picture or any shape of picture into the at any surface, but this is for icing drawing lah. Cake top, for cake top. This can use variety. It can use at many places. Marking, icing, drawing, pen drawing, sticker cutting, and whatsoever. This is for additive manufacturing. For the subtractive manufacturing, as I said before, cut a sticker. The sticker has been cut by a plotter machine. All right. So in the topic, the second topic is problem statement. Okay, what is the problem statement for this project? Okay, listed below is the problem statement. Limitation of only one process on one machine. possibility to imprecise position when moving workpiece into to another machine, which is process change from CNC process CNC router process to CNC laser process. In the middle of changing the process, maybe there will be some error that been made by a human error caused by our own self, and the product will not be precisely accurate. Okay. The third thing is time consuming on machine preparation for every process change. As I said before, every time when we want to execute a process of a machine, we need to make a preparation to ensure the machine is in a good condition, in a safe condition to run, and the position of material is in a perfect place before we can run the machine. Okay, this is time, very high consuming time process. Okay, the last one is only read a specific program. Okay, as what I mean by only read a specific program is if a machine, the machine is CNC router, it can program a CNC router program only. Is it is CNC laser machine, it can use CNC laser program only, and others. Okay, that is what I mean with only read a specific program. Okay, and the machine with 3-in-1 process is not available in market. There is no machine at the market that have 3 different process, which is have a laser cutting, have a router, spindle, and a plotter in one head. Yes, there is 3-in-1 machine and whatsoever, but I will show after this. Okay, this is the latest product of SnapMaker 2.0 A150, A250, A350. What is the mean of A150, 250, and 350 is the size. Okay, this is the bed size, the working area size. So this is the picture of A350, which is the widest surface for this type of machine. Okay, this machine have 3 type of feeder head, which is, you can see here, this is a router head, this is 3D printing hot end, and this is laser module. This machine is, yes, 3-in-1 machine, but it need to remove one and put one only on that machine. Only one process in one time. So what my project is all about is we want to make a machine that can run 3 process continuously without any post process of changing head, changing tools, and whatsoever. Yes, I know that at the industry we have a CNC milling, which is the CNC milling have automatic changing tools, but it's only specific on CNC milling process only, that the machine cannot do routing, the machine cannot do laser cutting, the machine cannot do a plotting. That's what is my project is all about. Okay, next. Okay, this is, after this I will show what is in the market, what type of machine in the market. So this is a Shopee market. Okay, this is only router, CNC, small scale CNC router only in this machine, but it have laser too. But same as SnapMaker, it need to change or can be operated one only in one time. Right. So this is laser cutting CNC, small scale CNC laser. And this is small scale of CNC plotter. I'm sorry, plotter machine. So this is a pen. This machine using pen. Okay, from these three machine, my project, what I want to do is we combine these three process to one machine, in one machine. Three process in one machine can be run in one time continuously without any post process, without changing the tool with our hand. It will automatically change. Okay, thank you for that. So we move to chapter 3, my objective and scope. So we'll explain about the project objective and the scope. Okay, this is project objective. The objective of this project are as follow: to design a control system which integrate process laser, engraving, and plotter. 3 process in one machine. Okay, that is my first objective. The control system must be merged. Okay, the second objective is to fabricate a low-cost CNC router machine control system with external controller. Fabricate a low-cost CNC router machine control system, which is mean from the control board system and what other things around it, with an external controller. The external controller is not in fabricate objective lah. It is another thing. Okay. The main point is to fabricate a low-cost CNC router machine control system. As we know, at industrial grade, we have HAAS and whatsoever board that have, but the control board is very what is called the price is so high. The price is so high. So I want to make a low cost CNC router machine control system for this project. Okay, for my third objective for this project is to evaluate the accuracy of design control system based on product measurement. So after we have designed the control system, fabricate the low cost CNC router machine control system, the last objective is to evaluate the control system of the accuracy of the system, which is we will draw an object or we will make an object with the same process. Okay, let's say plotting process, we make a we make rectangle shape 10 times 10. Okay, change process to laser cutting or laser engraving, move 10 by 10 and engraving 10 by 10. So we want to see the accuracy, is it the same or is the cutting place, cutting area at the same position? That is the accuracy test that I will do in the end of this project. Okay. Project scope. The scope of the project as follow. The system design is focused on automatic cutting element change on spindle or laser and marker. The machine will be developed by positioning the spindle, laser, and marker close to each other. Machine will be integrated by using machine language, which is G code and M code. The spindle will cut the large part, the laser make marking and cut small curve. The marker color the required part in one process. Okay, this is my project scope. Okay, the methodology. So this is the general methodology. From the start, we make a problem statement, literature study, and then circuit and algorithm design first, and then in this process we revise, we see what component that we need to do, to use what algorithm and whatsoever, and then circuit prototyping, which is circuit prototyping and algorithm development is it's like berkait. Okay, and then we will make test and troubleshooting. So if the test and troubleshooting is fail, we will revise on component and algorithm back again, and then test it until it's success, and then after completeness of every testing, we will make, or we will fabricate a circuit board and system fabrication process. We will make finishing. After that, after the machine is complete, ready, finish, and then we will do the accuracy test and then take data analysis, and that's the end of the project. So when for this flow chart, this is a component study and selection of component. All right, move here. This is the component that we need in this project. We have mechanical part, electronic part, feeder head. So this is the main part in this project. All right, so we move to mechanical part. We have linear shaft, bearing, ball bearing, linear ball bearing, lead, screw rod, and coupler. This is the coupler. Lead screw rod. All right. So for the mechanical part, part 2, the first picture is aluminum profile. Second picture is core screw, or we call it Allen key screw. The number 3 is hammered nut, which is the design is special for aluminum profile, and this is the installation diagram. Okay, we move to next part, electronic part. We use MKS DLC V2 as our controller, stepper motor as our actuator, and servo is our actuator for plotter mechanism. And the fourth thing is MKS TFT 32 board, which is this is an external controller. All right, so next we move to head, feeder head. Okay, for the first picture is the design of head holder, which is in this place we will put laser feeder, and this is servo feeder for plotter, and the round shape is for spindle. So this is the second picture is 24-volt spindle motor with 8,000 RPM, and the third picture is plotter head pan to be plotter head that we plan to use as the mechanism design. And the fourth picture is blue light laser with 1,000 milliwatt power. All right. So we will go to the next topic, which is initial result. Okay, this is my initial result. The initial result until today is listed as below. X, Y, Z axis movement is working. Spindle and laser is working. Laser burning is tested. Spindle and laser switching is working. Mission firmware study for pin mapping we have done. I have done it. Controller have done and still in study, because the firmware is too wide that I need to explore furthermore. Controller software is working. Head frame holder has been printed. Just for now, we print the holder first for prototype. So for automation and full run is still far away to be completed in BDP2, and that will be completed in BDP2. Okay, this is the proof that I have done the initial what's called initial result. So this is the condition, the machine and workspace condition at my home. Control board, we use MKS DLC V2 is working fine, just fine. Board pin and algorithm is studied by datasheet and firmware algorithm, which is in C programming, C++. The MKS DLC V2 pin is not same as Arduino Uno pin, no. The processor is the same with Arduino Uno, but the pin is different. Okay, this is the mapping for the MKS DLC V2 pin mapping. As you can see, this is the data sheet. All right, to know what is the function of each pin is by reading and modify the firmware, read the data sheet and read the firmware to know what is the function of each pin. The firmware is modified by Visual Studio Code, which is the Visual Studio Code is a software that we can go deep into C, which is called, as we know, Arduino IDE have a library. So we want to go inside the library. So this is the software that we use that is suitable and can be used, and it is free to use, no charge at all. It is absolutely free, and it is very nice it have a very nice interface. I can say that. Okay, this is the Visual Studio Code interface. Okay, the pin mapping can be found in this VS Code. We call it VS Code, and it is in C, not C++, in C. Okay, so for the switching mechanism, which I've been told before, stated before, that the spindle and the laser is working, but the laser and the spindle source is at the same point in a parallel line of supply, and the controller pin control, what is called, the power control, or what is the controller. Well, I'm sorry, Dr. Mr. Farid. What I mean is the power control pin is the same. It is in the same line. So for this, for my initial result, this is my solution. Which is maybe in future we can totally separate it to a separated circuit. This is my initial result. Okay. From the pin tree of analog pin tree at the MKS DLC board, we control the relay. So the relay will switch when I push or call a coolant button, coolant command. So the coolant is active, so the relay will active. If I close the coolant, the relay will off. So this is the switching mechanism that I use. Okay, and it is working. Okay, this is the controller interface. We use Ultimate CNC just for now. For now, we use Ultimate CNC. This is a free software, but to use more further, what is called, for more future in this software, we need to pay to them to unlock all features. Okay, so this is the coolant button, or the at here we have manual controller, also have coolant button. We can push the coolant button, and then with the coolant button we manipulate the regulator, the switch, the relay. I'm sorry. Okay, this is the test that I have made for the laser module. So as you can see, there is a heavy burn and there is a minor burn. So what I do here is the heavy burn is at a full capacity of power, so which is in 100% power, so it can cause cutting if we move slower. For the not for the light color one, is the percentage of the power that supply is low, so which is the power that I have control by PWM and it is working. So this is proof that PWM can control the laser power that can cutting or just plotting or just engraving. So the power that we can control. So this is the test that I have run, and this is using 100% of power, and the process is run automatically by using the software. I draw a square shape and then it run the laser cut nicely lah. This is the result. Okay, this is the condition. When the laser condition is in the run mode, the laser is blue color. Alright. So need to wear sunglass. Where is the sunglass? Okay. This is the sunglass that I need to wear for safety precaution. Okay. Alright. So we go next to conclusion of the project. So the conclusion is this project is harder than expected. Okay, the scope of only study on G code actually drive the project to go deep to until C programming. With the initial result, prove that the project can be done, inshallah, in BDP2. The research is still incomplete, and maybe more things can change, especially the method flow. As I have presented before, the method, maybe we will have something change, some change. Okay, expected end of the research, the machine can run 3 processes in one time, execute continuously with eliminating the preparation process before change in any process. Okay, this is my conclusion. So the last topic is project planning for my project from BDP1 until BDP2. So this is the Gantt chart. So in this Gantt chart, we can see my project timeline. So from the week 1, project confirmation, motor analysis, controller analysis, blah, 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 until today, final report. And the second BDP, for the second BDP in next sem, this is my plan. Machine algorithm, still in machine algorithm development and testing until the algorithm and the component is okay. And then we will move to circuit board and system fabrication for the last, or what is called final, for the finishing. Okay, and then after that we make the accuracy test and then data analysis, and the final report I will be do it continuously every 2 weeks, inshallah, and the project plan to end at week 10 of the next semester. Okay, that's all from me. Thank you. Have a nice day.